All right, guys, we're moving now on to a very important topic in the BMAT section to chemistry, which is calculations. Calculation comes up time and time again. Every single BMAT paper should have at least one calculations questions. So it's very important, guys, that you understand the key concept, which I'm sure you will, having done A-level chemistry, and also, guys, that you are very quick off your feet with mental maths because a lot of the questions require that skill and it's very important. So, without further ado, guys, let's go through some of these questions. So, BMAT 2019 is our first one. Question 18 says the concentration of Fe2 plus ions in a solution can be determined by titration with acidified potassium manganate solution. So, the ionic equation for this is given below. It says a 25 cm cube sample of solution containing Fe2 plus ions reacted exactly with 10 centimeters cubed of 0.05 molar potassium manganate solution, and it says what's the concentration of Fe2 plus in moles per decimeter cubed. So guys, pause the video, give yourself just under a minute, be sure to be back after that, and then we're going to go through the solution. All right, guys, so let's go through this together. So this is a really basic titration question. So this is the concentration of potassium manganate, which is going to be KMnO4, right? So that's going to be, so that's going to, and the way I know it's KMnO4 because I know MnO4 is just minus and the K is plus one charge. Therefore, to balance it, it's going to be one of each. So you have that much molar of KMnO4, and obviously KMnO4 can just dissociate into K plus and MnO4 minus. So that means that the concentration of KMnO4 and concentration of MnO4 minus is going to be the same. So that's going to be my concentration of MnO4 minus, and we use 10 centimeters cubed of that solution, right? So what I can do then is just a simple, remember, concentration equals moles divided by volume. Therefore, moles equals concentration times volume. So that means then the moles of MnO4 minus is going to be 0.05 times the 10. But remember, the 10, you have to divide it by 1,000 because the 10 is in cm cubed, whereas this over here is in dm cubed. So you divide it by 1,000 to get your common unit. And then that cancels. So basically, all you have to do to the 0.05 is divide it by 100, i.e. add 2 more zeros. So you get that. So that's going to be the moles of MnO4 minus. Then we need to find the moles of Fe2 plus that reacted with that, isn't it? So the moles of Fe2 plus is just going to be, as you can see, is a 1 to 5 ratio. Therefore, you just have to times that by 5. And that's going to give you 0.0025. Right, so that's going to be our moles of Fe2 plus. Now we have our moles, we can just work out the concentration, right? So then the concentration is going to be that 0.0025 divided by your volume, which in this case, what's the volume? You use a 25 sample, isn't it? So it's going to be 25 divided by 1,000. Remember, you have to convert the cm cubed into dm cubed because all our answers are in dm cubed. And then what I can do here is times top and bottom by 1,000, which is going to give me 2.5, I think. Yeah, 2.5 over 25 times top and bottom by 10, so 25 over 250. And then that's just going to be basically 1 in 10, isn't it? And 1 in 10, guys, gives you basically 0.1, or in standard form is going to be 1 times 10 to the minus 1 mole per dm cube. That's going to be E as the correct answer. So hopefully, guys, that has made sense. And as always, we look forward to seeing you in the next video. All right, guys. So previously, we were looking at this question, BMAT 2019, question 18. Quite a lot of arithmetic involved in there, but hopefully, guys, it wasn't anything too difficult. Now, guys, we're going to move on to the next one, which is question 22 of the same paper. So it says complete combustion of 35 cm cubed of straight chain alkane vapor gave 105 cm cubed of carbon dioxide gas. Both gas volumes were measured at the same temperature and pressure. And it says, which of the following is a molecular formula of the alkane? So, guys, pause the video. Give yourself a minute. Be sure to be back after that. We're going to go through the solution. Okay, so let's go through this, guys. So we have complete combustion of a straight chain alkane. So remember, straight chain alkanes have the general formula CnH2n plus 2, right? And then we're going to react this with oxygen completely. So then what we're going to get then is NCO2s because we started off with N carbons. And we're also going to get H2O. But what we're going to get of that is M plus 1 H2O because in total that'll be 2N plus 2 hydrogens there. And then that means then in total, it doesn't really matter, but we're going to get something N oxygen. The actual number you can actually find out from this. So from here we're going to get N plus 1 oxygens, and from here we're going to get 2N oxygens. So if you add that together, these two together, that will give you 3N plus 1 oxygens. So that value over there will be 3N plus 1 over 2. Just for completed, but it wasn't really necessary. Okay, then what we know that is we have 35 cm cubed of this straight chain alkane, and that gave 105 cm cubed of this guy over here, so the carbon dioxide. And this is at the same temperature and pressure, right? So you must recall, guys, this it's not really in the syllabus. I think it's a really good formula to know about for the BMAT. The formula PV equals nRT, right? What we know over here, guys, is that the temperature and pressure are constant, right? So if the temperature and pressure are constant, what I'm going to do actually is replace this for N. So N is going to be PV over RT, right? But what we know here is that the pressure and the temperature are constant, and R is also a constant. So then that basically means I can summarize this: N equals some other constant, call it CV. So what I know from this then is that the moles is directly proportional to V. That's what I know over there, right? So what that basically means, guys, is that I can treat the volumes as moles, if you like. So I can say, for example, this is 35 moles and that's 105 moles. So what must have happened here, guys, is that this is one of this reacting, and 105 divided by 35 is going to be 3. So that means this N over here was 3. So the N over here must also be 3. So we must have propane then, which is C3H8. So E, guys, must be our winner here. So hopefully, guys, you managed to pick up or already knew this useful trick, and hopefully you can apply it in a later question where relevant. But hopefully, guys, that has made sense. And as always, we look forward to seeing you in the next video. All right, guys, welcome back. So previously, we were looking at this question, BMAT 2019 question 2. Hopefully, guys, you were able to pick up on this skill, which is really important. Not only would it be important, guys, for the BMAT, but it might also be important for your A-level chemistry studies. Now, guys, we're going to move on to the next question, BMAT 2019 question 26. So it says diborane has a formula B2H6. Assuming that boron consists of two isotopes containing 20% of the 10 form and 80% of the 11 form, and that hydrogens are all 1. So it says molecules of diborane would therefore have relative masses of 26, 27, and 28. And then it says, in what relative proportion will molecules of diborane with masses of 26, 27, and 28 occur? So, guys, pause the video, give yourself a minute, be sure to be back after that, and then we can go through the solutions. All right, guys, so let's go through this. So we're assuming that hydrogen only has one isotope here. Obviously, that's wrong. Hydrogen has quite a few different isotopes. But we'll go over this assumption here. So that means that this 6 hydrogens by default would give you 6 in your MR, right? So that means in the case of the 26, the other 20 must be coming from the 2 borons. So here you must have 2 10s. And in the case of the 28, we have remainder 22. So then that means that both borons must be 11. So what's going to be the case in the 27 isotope then is the fact that you're going to minus 6, you get 21. So that means you have 110 and 111. Okay, so basically this is the probability. So what's the probability that I'll get a 10 isotope and another 10 isotope? So it's going to be 20%, which is going to be 1 in 5 times 1 in 5, which is going to be 1 in 25, right? And what's the probability I'm going to get a 10 and then a 1? Well, that's going to be basically, let's assume the first one is 10 and then the next one is going to be an 11 isotope, so that's going to be 4 over 25. But then remember, guys, that what you could have is that, so either what you can have is the first boron being 10 and the next one being 11, or the other way around. So this value over here, guys, you have to times this one by 2. I'm going to times this one by 2, which is going to make it 8 over 25. And then obviously we have the last option, which is both of them being 11. That's going to be 4 out of 5 and 4 out of 5. So 4 out of 5, and there's only one way that can really happen. So 4 out of 5 times 4 out of 5 is going to be 16 over 25. And can you see, guys, all these values, 1 over 25, 8 over 25, 16 over 25, they all add up to 1, as probabilities all should add up to 1. Okay, so then the ratio you'll get then is going to be 1, 8, 16. So 1 to 8 to 16. And that's 26, 27, and 28 isotopes. So that means, guys, the answer here then is going to be E. So hopefully, guys, that has made sense. And as always, we really look forward to seeing you in the next video. All right, guys. So previously, we were looking at this question to do with diboron, question 26 of BMAT 2019. Hopefully, guys, this was more of a maths question, I would say, rather than a chemistry question. But hopefully, guys, that has made sense. If you want more practice with this, guys, there's videos out there which I've done on probability, which might also be worth looking at, which might help you with this whole idea of, combinations and stuff like that. Now, guys, we're going to move on to the next question, which is BMAT 2018, question 14. This is the mass of atoms and molecules can be determined using a mass spec. The masses can be shown as a series of peaks. Element X exists as a diatomic molecule. The mass spectrum will show the mass of ions formed from individual atoms of X and from X2 molecules. The mass spec for element X is shown below, and it says how many different isotopes of X can be determined from this mass spectrum. So guys, pause the video, give yourself a minute, be sure to be back after that minute, and then we will go through the solution. All right, guys, so welcome back. So this is actually quite similar to the previous question. So if you remember the previous question, we had three, so you had like diboron, which has 2 borons, and you basically had 3 different mass numbers of that, right? This is also what you have here. So remember, guys, in mass spec, if you study that at A level, AS level, basically the highest peaks, what we call the molecular ion peaks, are basically due to the complete molecules, and basically these are going to be these 3 over here. These ones are going to be basically due to the complete molecule without the molecule fragmenting, right? If you want more details on how mass spec works, just drop a comment down below, guys, and I can try to explain that in the best of my abilities. But those 3 are going to be basically due to the molecules, and that means that these 2 are due to the molecule, so the diatomic molecule, which is fragmented, so it's formed 2 different atoms. And basically what we can see here is that there's 2 different types you can have. That basically means that if there's 2 different types of X we can have, that means therefore there's going to be 2 isotopes. And that makes sense, because if you have 2 isotopes, you can get 3 combinations of that. You can have 2 of one, or 2 of the other one, or 1 of each. And that's how you get the 3 molecular ion peaks that you can see downstream. So hopefully, guys, you can appreciate then that in this case, B is going to be the correct answer. So in this case, B, this is going to be our winner. So hopefully, guys, that has made sense. And as always, we look forward to seeing you in the next video. All right, guys, so welcome back. So previously, we were looking at this question, BMAT 2018, question 14. Very similar to the previous question, actually, we were looking at, which was concerning that molecule called diborane. Hopefully, guys, that question has made sense and you were able to pick up similar skills. Now, guys, we're going to move on to the next question, which is BMAT 2018, question 22. This is a compound of oxygen and fluorine has relative molecular mass, which is twice that of its empirical formula. 105 grams of the compound contains 57 grams of fluorine. What is the molecular formula of the compound? So, guys, pause the video, give yourself a minute, be sure to be back after that minute, and then we're going to go through the solution. All right, guys, so what we have here is we have a molecule which has, let's just say, X amount of oxygen and Y amount of fluorine. Assume that it breaks down to give X moles of oxygen atoms and Y moles of fluorine atoms. And what we have is 105 grams of this guy gives 57 grams of this. So that must mean then that the remainder must have been from the oxygen. And the remainder is going to be 43 plus 5, which is going to be 48 grams of oxygen. So we could work out the moles of oxygen here, oxygen atoms, by simply just dividing this by the AR of oxygen, which is 16. And for this one, it's 19. And if you do this, that's going to be 3, and that's going to be 3. So basically, what essentially we're doing here, guys, is we're working out the empirical formula. So that means in the empirical formula, you have a 3:3 ratio of oxygen to fluorine. But remember, the simplest, what you're going to find is the simplest ratio. Because remember, empirical formula, the definition was the simplest whole number ratio of atoms of each element in the compound. So 3:3 can be simplified to 1:1. So that means the empirical formula is going to be OF. But now what we know is that in the molecular formula, the relative mass is double. So basically, we have to double this up, right? And if we double that up, the molecular formula we're going to get is O2F2. So that basically gives us C as being our winner here. C is the correct answer. So hopefully, guys, that has made sense. And as always, really look forward to seeing you in the next video.